Hey guys, welcome to this session on TensorFlow tutorial for beginners by Intellipaat. TensorFlow is a very popular machine learning library by Google, but it can be a little difficult to get started with. Keeping that in mind, we've come up with this session to help demystify what TensorFlow is and how you can use it to build machine learning applications, especially by building neural networks. So with that in mind, let's begin with the session. But before we begin, please click on the subscribe button and click on the notification bell icon so as to never miss another update. Click on the like button if you like this video, and in the comments section down below, let us know what technologies would you like for us to cover next. Alright, let's take a look at the agenda for the session. We'll begin by taking a look at what is TensorFlow. TensorFlow is the basis of the presentation that we're doing, so we need to first understand what it is. Then we'll take a look at the reasons you should use TensorFlow. Why would you want to use TensorFlow? Then we'll take a look at the companies that are using TensorFlow in today's day and age. TensorFlow is one of the most popular libraries, so many companies are using it. We'll take a look at a few of those. Then we'll take a look at what are tensors. Tensors are what form the basis of what TensorFlow is. A TensorFlow uses tensors underneath the hood, so you may not have to create tensors on your own when you're trying to build a machine learning, deep learning model, but knowing what tensors are is still helpful. Then we'll take a look at a hands-on in which we'll be using TensorFlow to train a deep learning neural network. So we'll make full use of TensorFlow in that hands-on, and you can follow along with us as well. Just a quick digression. In case you have any questions regarding whatever we are covering in this session at any point of time, put them into the question box and our team is there to help you out. And if you wish to learn more about machine learning or TensorFlow in order to get ahead in your career, stick with us till the end of the presentation and we'll guide you through some of the resources through which you can learn these things. So with that, let's begin. Let's first take a look at what is TensorFlow, which is the basis of what we are going to learn in this session. TensorFlow is by far one of the most popular libraries out there. It's used by many companies. It is ubiquitous with neural networks in Python, but what it actually means is the thing that we're going to cover now. So TensorFlow is an open source machine learning library that allows us to perform machine learning with neural networks. TensorFlow is created by Google. It is an open source library. That basically means that you can take a look at the code that powers the entire TensorFlow package, and you can suggest edits to the code as well. These edits could be cosmetic changes such as the language in comments, whether or not a particular format in which the code is written is correct or not. You can suggest edits in those, or what you can also do is add some features into TensorFlow. So if you're someone who's been using TensorFlow for quite a while, you have the opportunity to influence how the library works. You can use GitHub for that. Just download the code, fork the repository, and then add the code changes that you want to, and then you can propose the changes. Developers at Google will take a look at the TensorFlow changes that you have performed, and if they find them to be worthwhile, they'll merge them with the next release of TensorFlow. That's the power of open source libraries. This is why TensorFlow is so popular as well, because it's created by Google and it's open source and it's really useful. So people add lots and lots of more features to it, and developers only let the features that are going to actually bring about any change into the system be merged into the repository. With that, it is also great for building neural networks. In case you ever tried building neural networks by hand, it is possible. However, it's quite cumbersome setting up the entire topology of neural networks, describing the number of layers, how the layers interact with each other, how many neurons you want to create, creating each neuron and then setting up the connections yourself could be a really complicated and cumbersome task. And if there is some error in the connections that you have created between the neurons, there could be a loss in accuracy. So in order to overcome this, TensorFlow takes a very different approach. It takes layers as objects in classes, allows us to define the structure of our neural network, then compiles those structures into a neural network or deep linked neural network, and then from there the training begins and it teaches the neural network how to perform the tasks. So let's take a look at why you should use TensorFlow. Many companies are using TensorFlow and we'll take a look at some of them in a moment. But why would you want to use TensorFlow? Why is it so popular? And what benefit does it provide? While TensorFlow offers several benefits for building neural networks, such as debugging is one of the major aspects that TensorFlow provides help with. When we're creating TensorFlow applications in the previous versions, we had to create something called a TensorFlow session graph. Now the graph was basically just a graph of computation. You basically had some numbers and then you wanted those numbers to be manipulated by several nodes inside a graph, and then you create those graphs. These were the neural networks and the neurons and the connections between those neurons with weights and biases. And after that, we would run the neural network and let it go through the entire process and then return the output. In case we run into some error, TensorFlow provides great facilities for us to debug the TensorFlow library's internal tools, and it allows us to figure out how to look at each variable, how the variables are being manipulated. So debugging is really quite nice with TensorFlow. Then comes documentation. TensorFlow has been around for quite a while. It's currently in its second version. The current version is 2.3 as far as I know. So TensorFlow has a great documentation. You can go to TensorFlow's website and take a look at the documentation available. The reason why it's also very great is because there are many different versions of TensorFlows available. TensorFlow 1 and TensorFlow 2 are one of those, but you can also use TensorFlow JS if you're trying to build a web application that uses JavaScript based machine learning. Then TensorFlow JS is there for you. You can use TensorFlow Mobile and IoT in order to build IoT applications that are machine powered by machine learning, or if you want to build mobile application that make use of a machine learning model that you have trained. And of course, TensorFlow is in Python, but TensorFlow Swift is also available that for which you can use the Swift programming language that is used in iOS application development. So as you can see, documentation available for different languages, different platforms, and all the documentation is quite good, really extensive, and you can follow along with the tutorials. The guides are really quite well done, so you can take a look at all of these. Then comes ease. TensorFlow is quite easy to use. If you've never used TensorFlow before, you can get straight into it, but we do recommend that you know a little bit of Python, object-oriented programming in Python, and the mathematical foundations need to be there. TensorFlow allows you to let go of the mathematical jargon that you would have to implement in Python. Instead, it gives you an entirely new set of APIs through which you can define your neural network, through which the data will flow and training will happen, and after that, we will get the output. So it depends entirely on how you want to do it. We recommend that you get a good understanding of mathematics and Python first, then try performing a little bit of a data science task, such as training a neural network to perform regressions and classifications, and from there on move on to neural networks using TensorFlow. After that, TensorFlow is really easy to pick up. You can easily understand how the structures are being created, what each structure is doing, how activation functions are working. Once you get the basic jargon out of the way, it's very easy to pick up. Then comes tooling. So tooling is another aspect of TensorFlow that is quite good. TensorFlow comes with several utilities and several tools that you can use in order to navigate through the entire TensorFlow ecosystem. One of those is TensorBoard. It's an online playground type application in which you can define the structure of your neural network and have it go through the entire structure and then separate data or classify data. And you can do it visually. You can tweak the structure visually yourself by adding nodes, deleting nodes, adding more layers, nesting those layers as deep as possible. But as the layers are being nested, you can see that there's a significant decrease in the speed at which the layers or the entire neural network is being trained. And that is quite obviously because as the layers become more dense, more connections are created, more computational power is needed to perform more mathematical inquiries. Now, when you want to just jump into TensorFlow and figure out how things work and what are the things happening, and you want to use visualizations, then TensorBoard is quite a nice application. TensorFlow has many other tools available for you. It has several extensions for several IDEs, packages that you can use to debug and to profile your data on your neural networks. It has libraries so that you can visualize the neural networks as well. There's a lot of packages and tools available for you to use so that you don't have to build these tools, and these tools are available for you right from the start. Then comes scalability. Now, scalability is one of the most important aspect when it comes to TensorFlow. The reason why Google is backing TensorFlow is because TensorFlow is really scalable. For those of you who are unaware, scalability basically means that TensorFlow works well for small neural networks, but for large neural networks also it can handle the data very well, and it can be used to perform and tackle really complicated machine learning algorithmic problems. So if you've ever come across a huge machine learning problem for which you have to create intensive data transformation pipelines and through which data should pass from each neuron, and then create different kinds of structures in order to process the data in a different way. For instance, if you have image data that needs to be processed using a different topology of neural networks, if you have audio data that needs to be processed differently, if you have textual data, then that needs to be processed separately. And TensorFlow is great for all of those. TensorFlow allows you to use all of these kinds of data points and figure out how to use them best to your needs. So it's quite scalable. The only thing that you have to understand is that there's a right way of using TensorFlow and there's a wrong way. There are many missteps that you can perform in order to degrade the performance of TensorFlow neural networks, and we'll show you some resources through which you can learn these things. But do keep in mind that that's how that might happen. Now, let's take a look at the companies using TensorFlow. As you can see that there are a lot of companies. Now these companies might be using TensorFlow in a very small scale project that is very internal to them, or could be using them in a large scale project where you can take a look at different applications and different data sets on the back end of the several applications. One of the major recent ways that TensorFlow is being used is by Airbnb, in which images that you upload on the Airbnb platform to display the kind of rooms that you're making available will automatically figure out the objects that are available there, and will show what are the objects that are available, what are the commodities that will be available to the people who pay and stay in your Airbnb. So just figure out as you can see, this is quite powerful, and not a lot of people are able to do this because they need a lot of huge data sets and huge computation power. And for that, you can even use cloud computing. This is why Amazon is so popular as well. But these companies, as you can see, ranges from Google to YouTube, Edgeverb, Oracle, Siemens, Ola, and many other companies as well. Many companies like Uber and Ola use neural networks as well to predict the prices that should be charged for a particular user based on the distance, journey, and so on and so forth. So with that, let's take a look at what are tensors. Tensors are the basic processing unit of a TensorFlow application. You don't need to understand tensors at all to get started with TensorFlow. But if you want to take a look at underneath the hood, if you want to contribute to the code, then you need to understand what TensorFlow is. So let's take a look at that. A tensor is a generalization of vectors matrices that is easily understood as a multi-dimensional array. So if you are ever confused about what tensors are, they are basically a multi-dimensional array. A tensor is a mathematical concept which can either be a single data point, it could be a vector, which is a list of numbers, it could be a matrix, which is a table of numbers, or it could have multi-dimensional parts as well. So it's a list of matrices, it could be a matrix of matrices, there could be n dimensions associated to a tensor. The reason why tensors are so popular is because of the dynamic ability to have several dimensions, and they provide easy interfaces for us to perform mathematical calculations on them. Tensors are really efficient when performing mathematical concepts on them, and for this reason TensorFlow uses tensors underneath the hood. Now again, if you want to create an application using TensorFlow such as a neural network, you may or may not need to know tensors at all. As we'll see in our demo or in our hands-on, you don't need to know tensors that much in order to get started with TensorFlow. However, knowing tensors, knowing the basic mathematical concepts behind them can be really helpful. So now let's take a look at a hands-on. If you wish to perform the hands-on with me, you can. You just need a Google account, that is a Gmail account or whatever kind of an account on Google. Go to google.com. Once you go to google.com, search for, let it load first, and then you have to search for Google Colab. Think of it as Jupyter Notebook, but on the cloud. If you want to learn more about these technologies, what is Jupyter Notebook and all, don't worry. At the end of the session, we'll guide you through the resources through which you can learn these things. For this session, we recommend that you know at least a little bit of Python, the syntax, and yeah, that's all you need to know. So make sure that you're signed in. Then go to colab.research.google.com. After you reach there, click on the new notebook button right underneath, and it will create a new notebook entirely for you. So this new notebook is going to be backed by Google's cloud platform, GCP, if you have heard of it. It will create a new notebook in your Google Drive, and that notebook is then going to be mounted inside a Google Cloud Platform server. That server is going to be responding to the code that we run, and we can run Python code. So if I want to run some Python code, I can just write print hello. If I run this, as you can see, it's saying allocating and then connecting. Once you start running the code, you'll see that it firstly connects to a server. After that, we'll see a few vital signs such as the RAM and the disk space being acquired by our code. As you can see, it's there. So now it's working and it gets back the response, which is print hello. Now, let's get started with the code that we're about to write. So, if you have ever worked with TensorFlow before, you would know that there's a lot of complicated setup that you might have to do. Well, with TensorFlow in Google Collaboratory, everything is set up already for you. All you need to do is just import the libraries and they're available for you. So we're going to import some of the most common ones. NumPy is NP, and the other library I want is for visualization purposes. We'll import matplotlib.pyplot as plt, and finally the thing that we want to insert is TensorFlow as tf. As you can see that these are so common that Google Colab already gives you hints to how to perform those. I run the code, and to run the code, just highlight the code cell that you want to run, press shift and enter, and it will work. Or point your mouse towards this arrow or the run cell button, each cell, and it will run the code for you automatically as well. So with that, now we have imported the libraries that we want to. The task that we're going to perform is we're going to create an image classification algorithm. What it will do is it will take a look at digits inside an image and tell us whether or not it's a number from 0 to 9 and which number is it. So now I want to get the data. To get the data, it's the MNIST dataset as it's called. I will use tf.datasets. And inside I'm sorry, it's not tf.datasets, it's tf.keras.datasets. And as you can see, there are a lot of data available for us. I want the MNIST data. So I run this and I have gotten the reference for it. Now I want to split it into test and training part. Now, since it is a data frame available inside our TensorFlow library, they have already done it for us. I just need to know how to extract it. So xtrain, ytrain, xtest, and ytest are two things I want to extract. Xtrain, ytrain, xtest, and ytest. So we have testing and training data sets already split up for us. All we have to do is use the MNIST variable that we had assigned earlier, and load data is the function we have to call. As soon as I call it, you will see that it is downloading the data. And since it's connected to a Google server, it's really fast. And we have got the data that we want to use. Now let me just show you what an image in TensorFlow would look like if I want to see. So I want to use the imshow function. Imshow is a function on matplotlib's pyplot object. And I want to pass in an image. The image is going to be xtrain first image, and CMap is going to be the color map, and the color map that I'm going to use is the gray color. Now after doing this, I want to just show the image. So plt.show. In this line, I am instructing matplotlib to draw some image on its canvas, and in plt.show, I am asking matplotlib to return the image on the canvas so that I can show it. I run this, and as you can see, it's showing me 5. The first digit that we have should contain 5, and we'll take a look at that. Now that we have gotten the data, let's normalize the data. Normalization basically means getting the data and putting it in a way that removes some outliers and corrects for any biases and errors available. So xtrain is going to be tf.utils. And as you can see, utils has a lot of method, but it's not on utils. I think it's in keras.utils here. And normalize. There we go. So to normalize the data, all we have to do is pass in the xtrain data and specify the axis. So xtrain axis is equals to 1. And similarly for xtest. And we also specify the axis to be 1. Axis 1 basically means we want to normalize it on the y-axis. So we'll take a look at what that means in a moment. Just press shift enter, run the code. It runs, and now after we have gotten our code to run, we can create our neural network. But first, let's take a look at the data that we have. I'd like to show you what it looks like. So as you can see that these are arrays of arrays of arrays of arrays. So if I were to run the length function, you will see that we have 60,000 data points here. If I were to go to the first one, 28 pixels are there. So what happens is we have an image of size 28 by 28. If you take a look at how big that is 784 pixels. So what's going on is that we have 28 rows, 28 columns, and each row and column contains a number that describes how bright a particular pixel is. And that data on itself is not very useful, but when you combine it together, reshape the data into 28 by 28, and then use the color map gray that we used earlier. So what happens is 0, 0 is 0, so it's completely pitch black. As we go ahead here, the number might have been 0.6, so it's a little brighter. Here the number would have been 1, so it's completely bright. So that's how it's working. Now that we have the data and we understand the shape of our data, let's create a model. We're going to create a sequential model, and to create the sequential model, all I'm going to do is type model is equals to tf.keras.models.sequential. So if you are wondering why we're using keras here, keras is what's used behind the scenes in TensorFlow. Keras is imported behind the scenes to do a lot of different kinds of things. It's not the exact keras library that you would use when you download it. There are some bits removed and some bits added, but overall it's the same. Now after getting this, we want to create layers, or we want to add layers. These layers are actions that we want to perform on the data. The first layer we want to do is called the flattening layer. So we go model dot, and let's take a look at the we want to add data to the model or the layers, and to add it, all I have to do is create tf dot keras dot, and if you take a look at it, the first thing that it gives me is layers dot, and I want to flatten the layer. Flattening basically means that if I have some two-dimensional array, I want to convert it to one-dimensional, so a single series of data. After doing that, think of it as operations being described in a pipeline. Now I want to create a dense layer, and that's how I'm going to do it. Dense layer basically means layers with neural networks, and we have to define the topologies here as well. So we go tf.keras.layers. And as we have already discussed, we want a dense layer. So I will just dense. Inside it, I want to type in the units. So 128 units are supposed to be there. And activation function. This is a function that plays a role in how we are going to decide whether or not a particular neuron worked well or not, or did it capture the information or not. So to do that, we just use the ReLU activation function. Right, that is done. Now I want to add another layer. Here I've added a dense layer. Now I want to add another dense layer with the same parameters. So it's going to have two layers by now. 128 and ReLU, yeah, they're fine. And then I want to add another layer in which the activation is going to be, instead of it being with the unit of 128, I want the unit to be 10. The unit is 10 because the numbers that we have will range from 0 to 9. So each image can contain only 1 out of 10 possible values. So the output layer is supposed to be 10. Now after doing 10, I want activation to be equal to softmax. So instead of it being ReLU, softmax. And softmax is usually the activation function used in the output layers. So we have added all the 4 layers that we want to. If I run the code now, it should run, and it does. Now I want to compile our model. Compilation basically means I want it to be consolidated into a single unit that can be run later on. As you can see, the default optimizer is RMS prop, but I want to change the optimizer to add. Optimizers are basically functions that will take a look at how poorly your model is performing and will change its course and in order to optimize its training performance. So we'll use the Adam optimizer, and loss will be equal to a sparse categorical cross entropy, as far as I'm remembering. So sparse underscore, not entirely in one word, categorical, sparse categorical cross entropy. After doing that, all we want is for metrics, and the metrics basically means when you evaluate this model, make sure that you're checking its accuracy. We want the accuracy to improve as much as we possibly can. So if I run this, it works, and now I want to train it on the data. Training basically means fitting. So I'll fit it on the data, and I want to pass x to be equal to x train, y to be equal to y train, and now I get to decide epochs. Epochs, in case you're not aware, is basically training iterations. How many times do I want to train this model? The more number of epochs you get, the more number of iterations it will have, the more time it will have to correct its course, but it will take a lot more time to train the model. So you just need to figure out the correct number of epochs by trying out different values. By default, I'm picking 5. By default, it's 1, but I'm picking 5. So as you can see, the first epoch is going. We are training the model for the first iteration. Now we're training it for the second iteration. Now we're going for the third iteration, then for the fourth iteration, and finally for the fifth iteration. And in this, we are getting the accuracy of somewhere around 98.68. As you can see, the accuracy kept increasing. The first iteration had 92.05, then 96.75, 97.77, and 98.36, and then 98.68. The reason why we got that is because we have specified the metrics to be accuracy. Now that that is done and our model is trained, now let's take out the test loss and test accuracy. And here to do this, I just use the model dot evaluate function. As you can see, I don't have to create functions of my own. It is done for me already. So now all I have to do is pass in x test and y test, the testing data that we had set aside. X test and y test is passed. I run this, and we have gotten the accuracy of 96.77 on our testing data, which is quite good. If you want to take a look at that accuracy, then you can just test accuracy, print it, and it's the same as 96.77 as it is here. So now that we have done that, let us try and make a prediction. So we'll make a prediction on, and I want to predict on the X test dataset. So I have multiple data in X test. I'll just do that. Make the prediction. Predictions are made. Now if I were to show you what the predictions look like, you'll take a look at this and you will see that there are a lot of numbers ranging from 1.1 to however much number. Let's just take a look at the length of this. We have 10,000 values. So there are 10,000 values, and if I take a look at X test, it should also give me 10,000. So there are 10,000 values in X test, and similarly 10,000 values in predictions. But if you take a look at the first number in predictions, or first member in predictions, it has 10 numbers, right? So if I were to print those 10 numbers, as you can see, this is the number. So from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the number that has the highest value, or the index that has the highest value, is the neuron that was selected and or had the highest, the neural network predicted as being the highest with the highest confidence, and that is the number that it predicts to be inside our test. So let's just take a look at what the image shows, and we'll also take a look at the predictions. So if I were to take a look at np.argmax, and the number that we want to pass in is predictions of 0. If I run this, 7 is the number that is given to us, but if I want to plot it, then I just have to type in plt.imshow, which is to show an image. The image that I want to show is the first image, so x test of 0, and I want to pass in the cmap to be equal to gray. Then just use plt.show, run the code, and as you can see, it is 7. I think I misspelled it. Let me just do that. Yeah. So the number that we predicted was 7, and this is 7. If you take a look at the next one, it's also going to work. So we take a look at the numbers. These are the numbers. If you take a look at the numbers and figure out which one has the highest value, it's, I think, the third one. So we'll just take a look at this. And 2 is the number that has the highest prediction. So the number should be 2 as far as I can see. So it's 0, 1, and 2. Second index has the highest value. So the number it should have is 2, and it is 2. So as you can see that our neural network is trained with no time at all. We didn't have to write a lot of code. Defining the neural network was just these 5 lines of code in which we had to define the structure of the neural network. This is where most of the things that we do come into play. So we recommend that you play around with it a bit to get a bit comfortable with how neural networks work underneath the hood. With that in mind, we've come to the end of the session. Thank you so much for joining us. Let us now guide you through some of the resources that can help you out into learning more about TensorFlow, machine learning, and many other kinds of things. These resources are going to be helpful for you in order to grasp the basic concepts and can help you get a jump start in your career in case you are a complete beginner. With that, thank you so much, and now let's take a look at the resources.